Right now, there are over 50,000 cargo ships moving across our oceans. On those ships, about 20 million containers. And chances are, at least a dozen items within arm's reach of you right now traveled thousands of miles on one of them. But here's the crazy part. A single t-shirt might cross the ocean 3 times before you ever wear it. The cotton grows in India, gets shipped to Bangladesh for spinning, then to China for manufacturing, and finally to your local store. Welcome to What Keeps It Running. I'm Alfred, and today we're unpacking the absolutely massive system that delivers 90% of everything you own. Let's start with something that'll blow your mind. That shipping container you see on trucks, it's called a 20-foot equivalent unit. It's the Lego brick of global trade. The biggest cargo ships today can carry 24,000 of these containers. Stacked up, that's taller than Mount Everest. And here's what really matters. This entire system runs on something pretty simple, a metal box with standard dimensions. Before 1956, shipping was chaos. Dock workers would spend weeks loading and unloading ships with individual boxes, barrels, and crates. Then a trucking company owner named Malcolm McLean had an idea. What if we just put the truck trailer on the ship? That simple idea cut shipping costs by 90% overnight. It's why your smartphone costs $1,000 instead of $10,000. Shipping it from China to the US, about $2, less than your morning coffee. But let's follow an actual product, say, a pair of sneakers from factory to your front door, and see what really happens. Stage 1. The factory floor. Your sneakers start in a factory, probably in Vietnam or China. The moment they're made, they're packed into boxes, and those boxes get loaded into a container but not randomly. There's an entire science called container stuffing. A standard 40-foot container can hold about 2,400 shoeboxes. Too few, and you're wasting money. Too many, and you risk damage. Companies use software to calculate the perfect Tetris puzzle of boxes, pallets, and products. Once stuffed, the container gets sealed with a unique number like a tracking code and heads to the port. Stage 2. The port. Here's where things get wild. Think of a port like an airport, but instead of planes, you have ships the size of skyscrapers lying on their side. Your container arrives by truck and enters a massive holding yard, often the size of 100 football fields. Automated cranes, some controlled by operators sitting miles away, stack containers like playing cards, sometimes 6 high. When your ship arrives, giant gantry cranes these things cost $10 million each grab containers and load them onto the ship at a rate of about 30-40 containers per hour. The largest ports, like Shanghai or Singapore, handle over 40 million containers per year. But here's the part nobody thinks about. Where you place each container on the ship matters hugely. The physics of a container ship. These ships are engineering marvels. They're designed to balance weight perfectly. Put too many heavy containers on one side, the ship lists. Put them all at the bottom, it might be too stable and rock violently. There's actual software that calculates the perfect 3D puzzle to keep the ship balanced through storms. And storms are serious. Container ships regularly face 30-foot waves. About 1,500 containers fall off ships into the ocean every single year. That viral story about rubber ducks washing up on beaches? That's real container spills happen. The journey from Shanghai to Los Angeles takes about 14 days. During that time, your container is stacked with hundreds of others and might shift through 3-4 different ports. The route. Ships don't just go straight across. They follow established shipping lanes, which are like highways of the ocean. And they make stops, because it's more efficient to load and unload at multiple ports than run direct routes for everything. This is why something shipped from China might actually go to Singapore first, then Los Angeles, then get transferred to a smaller ship to Seattle. It seems inefficient, but mathematically, it's brilliant. It's called hub and spoke logistics, the same system airlines use. The fuel situation. Here's something dark. These ships burn the dirtiest fuel on Earth, bunker fuel. It's basically the leftover sludge from refining oil. A single cargo ship produces as much pollution as 50 million cars. The entire shipping industry creates about 3% of global CO2 emissions. But here's the twist. Per item delivered, it's still more efficient than almost any other method. Moving one container from Asia to Europe by ship produces less CO2 than driving a truck across Europe. Customs and unloading. Your container arrives at the Port of Los Angeles, the busiest port in the Western Hemisphere. Before it even gets unloaded, customs officers are scanning documentation. Every container is X-rayed or inspected. They're looking for illegal goods, misreported items, or safety hazards. About 5% of containers get flagged for physical inspection. If yours does, add several days to delivery. Once cleared, those same massive cranes unload your container onto a chassis, essentially a trailer frame. A truck hooks up and hauls it to a distribution center. The distribution center. This is where Amazon, Walmart, or your sneaker company's warehouse comes in. Inside these massive buildings, often 1 million plus square feet, your container finally gets opened. Workers, or increasingly, robots unpack the sneakers, scan them into inventory systems, and sort them. Some might go to stores, others get stored until someone orders them online. The last mile. This is the most expensive part of the entire journey. That $2 ocean voyage, the final 10 miles to your house, might cost $8. Your sneakers get packed into a box, labeled, and loaded onto a delivery truck. That truck might make 150 stops in a day. The driver is optimizing routes in real time, fighting traffic, and racing against the clock. Finally, anywhere from 6 to 12 weeks after leaving the factory, your sneakers arrive at your door. Why this system is fragile. Remember 2021, when a single ship the Ever Given got stuck in the Suez Canal for 6 days? It blocked 12% of global trade. Hundreds of ships sat waiting. The backup caused billions in losses, and you couldn't buy certain products for months. That's because global shipping runs on something called just-in-time delivery. Companies don't stockpile goods anymore. They order exactly what they need, exactly when they need it. It's efficient, but one broken link breaks everything. COVID exposed this even more. When Chinese factories shut down, when ports got congested, when there weren't enough truck drivers, the whole system nearly collapsed. That's why everything got expensive in 2021, 2022. The future. So what's next? Autonomous ships, crewless cargo ships are already being tested. Could reduce costs by 20%. Green fuel. Companies are experimenting with hydrogen, ammonia, even nuclear-powered cargo ships. Nearshoring. More companies are moving factories closer to customers to reduce these insane supply chains. Amazon effect. Faster delivery expectations are forcing the entire industry to speed up, which is really hard when you're moving millions of tons across oceans. Look, the next time you order something online or pick up literally anything in a store, just take a second to appreciate the absolute miracle of coordination it took to get there. Thousands of people, hundreds of companies, dozens of countries, all working together often without even knowing it to deliver one pair of sneakers to your door. It's not perfect. It's not always pretty. It pollutes. It's vulnerable. But it's also one of humanity's greatest logistical achievements. That's what keeps it running. If you enjoyed this, subscribe for more deep dives into the systems that power our world. Next time, we're looking at how the internet actually gets to your house. And trust me, it's way weirder than you think. Thanks for watching.